In this lesson, I'll show you two examples on how to calculate heat in a reaction. Question 1 reads, how much heat in kilojoules is released when nitrogen and hydrogen react to form 50.0 grams of ammonia? What we've been given in the question is the mass of ammonia and the delta H, which is the change in enthalpy for this reaction. What we want to do first is organize our numbers. So I'll write down that the mass of ammonia is 50.0 grams. And using the molar mass of this molecule, I can find the number of moles because we need the number of moles to calculate the energy. So I'll write down N, that represents moles, and the molar mass can be found using information from our periodic table. So we have NH3, NH3. The molar mass for nitrogen is 14.00. So I'll write down 14.00 plus the molar mass of hydrogen. We have 3 hydrogen atoms in this molecule, so 3 times 1.01. And we end up with a molar mass of 17.03. Let's write that down. 17.03 grams per mole. If I multiply 50.0 grams times the flipped version of this, notice that we have 17.03 grams at the top and 1 mole at the bottom. If I write it down as 1 mole at the top and 17.03 grams at the bottom, this unit and this unit will conveniently cancel out, leaving us with the amount of moles. So 50.0 times 1 divided by 17.03, that gives us 2.9359 moles. 2.9359 moles, and we need this to 3 significant figures, so we should have 2.94 moles. There are 2 molecules of ammonia produced, so we can write the delta H as negative 92.2 kilojoules per every 2 moles of NH3. If I multiply this number with this ratio, the mole unit will cancel out, giving us the amount of heat in kilojoules. So let's use our calculator once more. The number on our screen, and notice that the number on our screen was the one that was not rounded. Technically, you don't want to round until the very end, so that's why we're using that number. Multiply 2, negative 92.2. Both are 3 significant figures. Divided by 2, we end up with negative 135 kilojoules. That is the amount of heat released when nitrogen and hydrogen react. Moving on to question number 2. Mercury 2 oxide decomposes to mercury and oxygen. And the chemical formula is shown right here. Is the reaction exothermic or endothermic? That's easy to answer. Our delta H value is positive. When delta H is positive, it's endothermic. How many kilojoules are needed to react 25.0 grams of mercury to oxide? So we're looking for the energy when we have a mass that is 25.0 grams. Just as before, we can do the same thing. We can write down that 182 kilojoules per every 2 molecules or 2 moles of HgO. We've been given the mass, and we can also find the molar mass using the periodic table. So we're using HgO. Let's find mercury here. Mercury is found right here. Its molar mass is 200.59 plus 16.00. That's the molar mass of oxygen. Adding those up, we get 216.59. 216.59 grams per mole. I'll be multiplying this number to this number, but again, this one will be flipped. So 25.0 grams times 1 mole at the top and 216.59 grams at the bottom. This will cancel out with that. 25.0 divided by 216.59. That's the amount of moles. And just as before, we'll take this number and multiply it to this ratio. So this number times 182 divided by 2, and that's the amount of energy in kilojoules needed to react 25.0 grams. So to three significant figures, 10.5 kilojoules.